Good morning, myself, Krishna, and 2025 started. This is my first video in 2025. I would like to appreciate if you can subscribe this channel. It will motivate me and really help me to work on many technical things and make video for you guys. So coming to today topic is about random forest, but before I can go to random forest algorithm, I will just try to recap few things about machine learning. So we know on the high level we have two types of machine learning. One is supervised machine learning, second unsupervised machine learning. In supervised we have classification, regression. Second, for unsupervised we have clustering and association. When we talk about supervised, we are talking about label dataset. So in the label dataset, what is the meaning of label dataset? It is always paired with an output label. So here you can see we have feature and target. So we are predicting salary against age for 23. If it is 45K, these are the given data and this is the prediction. And in machine learning, we need to find out some equation where it is it will best fit for our prediction. Now coming to unlabeled, like it is not paired. So here you can see like unlabeled data set. So the unlabeled data set mostly we use for identifying the recognized pattern. Like in this customer, if you need to find out they spending a score, like which group age of customer is spending more based on this data set. So some group you can enable and you can figure out the patterns. So classification, we know here outcome should be binary. And for the classification, these are the algorithm. I already talked about logistic. Few algorithm I already uploaded video. If you get time, you can start going through my previous recorded video. So here, this algorithm classification supports logistic decision tree, random, SVM, neural network. But today we will stick to random forest. And here my outcome would be binary. So in your given data set, just think you need to find out whether this patient is diabetes or not. So to take this call, you just need to mark Boolean outcome. So by giving yes, no, true, false, you will get to know like this is diabetes patient. Yeah, this is non-diabetes patient. Coming to regression, this is supervised learning. And for the supervised learning, um, this will be continuous prediction. Like yeah, if you can say, firstly we can say what our algorithm it supports, like linear regression, decision tree, random forest, support vector regression, SVM we used to call, and neural network. So most of the algorithm you can see is common for this um, for classification and regression, and both work on the label dataset. So here in this dataset, like you are doing a prediction, like if this square feet is given number of room, yeah, age of house, you can predict the amount. So this is going to be continuous value. So here you are not predicting true false like this classification. So uh, here you are predicting in supervised learning continuous value. Clustering, we will this is unlabeled data set. So if you see here, like I said, uh, you need to identify pattern like uh, customer. Uh, based on the spending score. Like this age of customer is have spend more money. So some pattern you can identify for the given data set. Like for me, it is customer segmentation data. For you, it can be order segmentation data. So if you are in any of the promotion project, you can see like they are finding like which order, which customer has placed more number of orders. Yeah, if they have some portal where customer keep coming, what they are accessing more, what they are exploring more. Like if you have Flipkart website, they have they can figure out like if customer is going there, what it is more attracting, which product they are attracting more. So those sort of those sort of things we can find out here. Association is also like prediction. Like if some customer is buying bread milk, some customer buying bread diaper beer egg, you can say some customer buying this one. So based on the grouping, it will going to suggest you like if you have you bought milk beer, maybe you need beer Coca-Cola based on some other segments of the grouping. So like in Netflix, you can see some people are watching science fictions. If they watch any of the movie like Interstellar, yeah, any of the science fictions, it will suggest you another science fiction movie. So similarly, this pattern is for part of unsupervised. And if we can say algorithm, it supports a priori algorithm, ECLAT, FV growth, and this example I just spoke. Now we can go to random forest. At least we can try to see what exactly the terminology in random forest. And in future, I mean, in my next video, I would be talking uh, how we can um, uh, how we can how this random forest work on some examples. So this part, random forest algorithm is an ensemble learning technique. So what is ensemble learning technique? When we say ensemble learning the technique, it is like we are talking about group decision. We are like some set of set of tree, some set of group we are going to set up, and each group we are collecting output, and based on the output we are making final call here. So that's why it says ensemble learning technique. So if before coming to random forest algorithm, you should know what is decision tree. So in decision tree, we mostly talk about one tree. Here, random forest, you are going to have number of tree. And in many set, like in one set, some tree are giving you output. Another set, some trees are going to give you output. Similarly, another set, some trees are going to give you output. All three you are going to take average, yeah, any mean to figure out what is the final outcome. That's why we call this algorithm as random forest, where number of tree, and this is very accurately do the prediction. And most of the people use this algorithm because this algorithm is used in both the machine learning patterns, supervised and supervised. So this is one of the important algorithm I thought to talk today. And second point is bootstrap aggregation. So what is bootstrap aggregation? So just think when you are going to set the groups, like we have we have 300 number of employees. What we are doing, we are picking 100, and out of 100, we are picking who all are OIC resources. Okay, we got five. again, what we are doing, again, we are returning them to same bucket, and again, we are picking 100. So again, we are getting, okay, uh, in this 100 employee, we have 10 voice resource. Again, we are returning them. Again, we are picking 100. So we iterated, we made three set where our output came 5, 10, 15. So what we are doing, we are taking mean, uh, 10, 15 plus 5, which is going to be 30, and 30 divided by 3 means 10. So now we are saying this has 10 employee. So we are, I guess in the below slide I have given. So here you can see number of decision tree. Each tree has node left, right, and this data set. Eventually they are predicting 1, 2, 3 number of prediction they are making, and we are aggregating prediction and making final call. Similarly, like this is the data set, any of the data set you got. And in this data set, you can see we are split it into three n number of group, 1, 2, 3, 4 goes up to n. Here, we are making decision in all the tree, and based on majority vote, we are aggregating and making final prediction, that is random forest. So what exactly we have dealt here in decision tree? If you remember, outlier was the big problem. Um, but here, since we are aggregating and taking average, so we are resolving outlier issue here. So random forest typically achieve high accuracy and robustness. This is approach. And random forest reduce the risk of overfitting compared to individual decision tree due to averaging of prediction and feature randomness. So it is less sensitive to noisy data and outliers. And what are cons? It is complex. To do all those things, you need lots of resourcing. It's not like few people can do that. You need to first decide how, like bootstrap data split, data aggregation, badging we used to say. So first you need to figure out how you are going to prepare the set, and how you are how this is going to predict. And once decision is made by all the sets, you are taking majority and calculating. So this is problem is complex, especially you need to engage many people to do this job. Uh, Training and prediction can be computationally intensive, particularly with many tree and large data set. It requires more memory compared to simpler model. So this is all for today. I will be catching tomorrow with some new videos, and be connected. Thank you for your time. Bye bye.